All right, this video is going to help with part 2 of our derivative. So we're going to focus on word problems and kind of application because there's lots of applications for derivatives. So the first thing I want you to realize is let me share. I wrote it down. Some people need to see and hear. Boom. Okay, so the first thing, reminder of the formula. Okay, we have the 4-step process. That the slope is a function, the derivative is the slope of a function at any point. Okay, so we can find our slope of a function using derivative. We can find the slope of the tangent line. Okay, we can find the instantaneous rate of change, the velocity, and the last one, the change in x over the change in y. That's important. Okay. So let's look at our first example here. And this first one is our average rate of change. Okay, and we want to go from 2 to 4. What is our average rate of change from 2 to 4? And our function will be p of x equals x squared plus 5x minus 3. All right, so for this one, we can do our idea of change in x over change in y. Okay, so think about our change. Our change in our x values over our change in y. So I want you to think of this as putting in our value of 4 and subtracting off our value of 2 all over 4 minus 2. Okay? So it's the change in x over the change in y. I'm saying that backward, aren't I? Change in x, it's a change in y over, no? Change in y over change in x. I am saying it backward. Whatever. I'm losing my mind today. This is my 4th video. You'll be like, she should have slept a little longer. Okay, so the whole idea is we're going to do our change in y. So we're going to plug in our x values to get out the y. So we're going to use our function for our 2 values, and we're going to subtract them. That's going to be our numerator. Then we're going to do our denominator will just be subtracting our x's. So change in x. So change in y over change in x. Okay, so how am I going to do that? I'm just going to put it in our function. So I'm going to go, okay, what is p of 4? Okay, so p of 4 would be putting that in here would be 4 squared plus 5 times 4 minus 3. That is going to give me 1133. 4 squared is 16. 16 plus 20 minus 3 is 33. All right, and our p of 2 would be 2 squared plus 5 times 2 minus 3. That's going to give us 11. So 4, that's 10 minus 3. All right, so change in y over change in x, that's our symbol for change. So we're going to end up with 33 over 11, or minus 11 over 4 minus 2, which is going to give me 22 over 2, or it reduces to 11. So if you're asked the average rate of change, way easier than anything else we'll do today. All you're going to do is plug in your values because you're going from one number to the next. You're going to plug in your values into the original, subtract those on top, change in y, And then on the bottom, you would just subtract your two numbers. Okay, which is kind of the idea of slope. So what if I wanted to know the instantaneous rate of change at x equals 2? All right, so we're going to use the same formula. So maybe I'll call this part B. We'll call that part A. So what is the instantaneous rate of change formula? Let's start there. Oops. Instantaneous rate of change formula. So what is the formula for that instantaneous rate of change? Now I have to do my derivative because I'm not saying I'm going from 4 to 2. I'm not doing an average. It's not as easy. Darn it, because I liked that method we just did. So for this one, what we're going to have to do is find our derivative. So we're going to have our first step is plugging in that x plus h into our function. So we're going to take x plus h, and it'd be squared, plus 5 times x plus h minus 3. Okay, that's plugging in our x plus h, right? Step 1. Step 2 would be to subtract the original, use a parenthesis. The original is x squared plus 5x minus 3. Third step, divide by h. Fourth step, take the limit as h approaches 0 of all that. So step 1, step 2, step 3, step 4. Okay, so we're going to simplify it and go from there. So lots of simplifying across that top there. So this is squared, so I'm going to square the x. So x squared, 2 times this one would give me 2xh plus the h squared. Then I'm going to times this one through, so 5x plus 5h minus 3, and then these ones will just become negative, so, or change their signs, not necessarily negative, because the 3 will become positive. And I'm going to ignore the over h for just a second, and let's simplify this part here. So I see a negative 5x and a positive 5x. I see an x squared and a minus x squared. I see a minus 3 and a positive 3. So I'm left with these 3 terms. So I have 2xh plus h squared plus 5h over h. And so when I get those, just those last couple ones over h, I can see there's an h in everything. So I can divide out or factor out that h and cancel them so that this h cancels with the h here, cancels with one of the h's here, and it cancels with the h there, and I'm here. Now I can take the limit as h approaches 0. So I'm going to put in 0 for this h. So that's going to give me 2x plus 0 plus 5. So what is your final derivative? Your derivative would be p prime of x will equal 2x plus 5. The 0 goes away, and this is your instantaneous rate of change formula. Okay, what if I then asked, gotta leave that so we can see it. What if I then said, okay, if that's my formula, what if x equals 2? Okay, so if x is our number of items, what is the instantaneous rate of change if I sold 2 items? Okay, so I would put that into my prime, my 2, and I would have 2 times 2 plus 5. So 2 times 2 is 4. 4 plus 5 is 9. So this means when we sell our second item, the profit is increasing at a rate of 900, if this was in 100, 9 items or 900. I think the original problem had hundreds, which I didn't write down. So it's increasing by $9 per item. So at the second one, I'm increasing by $9. That's my instantaneous rate of change. What did I do? Found the derivative, put the value in. Okay, so it's the same idea. If I did velocity, so the average velocity, so I'm going to show this example here. It's it goes to here, and the average velocity of this formula, what if I ask the average from 4 to 6? What do? I can do the shortcut of change in y over change in x, if I can say it the right way. So we put in our values that were given into our original. Those would be our top, change in y, and then we subtract our 6 minus 4, and that is going to give me my average velocity from 4 to 6. So it could be the average, just the average rate of change, the average velocity, could be any of these things that we're talking about. So done the same way. All right, if I wanted to know the average velocity at x equals 4, average velocity at x equals 4, then I would know I have to find that derivative, okay? And the s is our function right here. I wanted it to still show. So what do I do for the derivative? I plug in the t plus h into the t spots. So here's our t spots, okay? Simplify. Then I subtract the original, okay? Subtract the original. Totally pause and try this to make sure you can do the derivative. Then I'm going to divide by h. It does cancel. I could take an h out of each spot. And then I do the limit, and here is my formula for velocity, okay, average velocity. So at 4 seconds, I can plug that in and I would get 13. What does that mean? It means after 4 seconds, we are increasing at 13 units per second. I didn't have a unit on there. Okay, so after 4 seconds, we're increasing 13. It's a slope, so we're increasing 13. We have a positive slope. So you can use it for velocity. Yeah, I didn't walk through that one all the way. You're welcome to pause it, try it. What if I wanted to do, let's see. What if I said, well, that one I feel like we could do one that's rate of change from one to the other. I feel like that one I think you'll be able to figure that one out. Okay, so this isn't problem 2. I don't remember what I'm on. I think I'm on 4. Could be on 5. Okay, so what if I say y equals x squared plus x? Now we need to remember that y is the same as f of x. So that is f of x as well. What if I say find the slope of the secant line? So part A is going to say find the slope of the secant line. Joining. So a secant line goes through a circle. It clicks on 2 spots. Okay. Joining 3, f of 3, and 12, f of 12. Okay. So here's our 2 points. What's the slope of the secant line through those 2 points? So what would I do to find the slope? Well, I'm actually going to have to calculate these values. I can't just say f of 3. And this says y, which is the same as f of x. Okay, so we're going to put in our f of 3. So we're going to find our f of 3, which is going to be 3 squared plus 3. And we're going to find our f of 12, which is going to be 12 squared plus 12. Okay, so 3 squared is 9, 9, 10, 11, 12. This is going to be 12. 12 squared is 144. 144 plus 12, I suddenly can't do in my head. I don't know why. You probably already have it. 144 plus 12 is 156. I don't know why. That just didn't want to add in my head. So those are our two values that we have for this one and this one. So we would then, to find our slope, we would say, okay, it's going to be 156 minus 12. 156 minus 12. Or, I mean, this way. But either way, this to this. And then over this one minus this one. So it would be 12 minus 3. Okay, 156 minus 12 is 144. And 12 minus 3 is 9. 144 divided by 9, does that go in evenly? It does, 16. Okay, so when I'm asked it in this method, people are like, what's a secant line? So we just got to remember a secant line is just touching in two places. So I just have 2 points. And to find the slope, I just have to find that y value to be able to find that slope. Okay, kind of like that rate of change, because it's the same idea. Slope is a rate. Oh, right. So then what if I said, I could say, so part A, oh, I did call that part B. What if your points are 3, f of 3, and 3 plus h, comma, f of 3 plus h. So what if I change those points to look like this? Same function, same question. Find the slope of the secant line joining these 2 points. So we would still need to find these two values. So f of 3 we know is 12. So we know that it's 12. We just found it. But what is f of 3 plus h? Well, we'll have to put that into our function. So we would have 3 plus h squared plus 3 plus h. So squared, okay, that's going to be 9 plus 6h. Plus h squared plus 3 plus h. Okay, so simplify this. You can add those couple things together. So I'm going to write this as h squared first, and then h, and that's going to be 7h. 3 and 9 make 12 plus 12. So we have that part there. Okay, so then I'm going to take that and I'm going to subtract off. So this is this. So I'm going to subtract this, which was 12, all over that 3 plus h minus 3. Okay, let's see what we get here. So this is here minus the 12. Oops, sorry. This here is here minus the 12, that one, and then that one minus that one. So y minus y over x minus x. So this is going to have these two cancel. So on the top, I have h squared plus 7h. And then on the bottom, I have h. So when I reduce that, I go down in h, and I would have h plus 7. Woo! So I thought the wording on the secant line was a little tricky, so I just wanted to make sure I showed you that. So definitely easier with numbers, but you can do it with the formula stuff as well. All right, I think you'll be okay on this, hopefully. There are a lot more examples that you can look at through the book as well. Okay.